Hi, everybody. Welcome to our webinar session today. We're going to give people just another minute or so to join us, and we'll get started. Thank you. Okay, let's jump in. Again, thank you everyone for joining us today. We're excited to go through the content of today's webinar with you, which is getting started with DevOps metrics. I'm joined by my colleague, Alex Pham. I'll kick it over to her in just a moment. Before I do, wanted to go through a couple of housekeeping items. First off, this webinar is being recorded, so you can look for that recording as well as the deck to come through to your inbox here in the next day or so. If you have any questions that come up throughout this session, please put those in the Q&A portion of your Zoom window, and we'll have the opportunity to answer some of those throughout, and then Alex will answer some towards the end as well. And without further ado, I'll pass it over to Alex, who is one of our customer success managers here at GitLab.
Awesome. Thanks, Taylor. Hello, everyone. As Taylor mentioned, our session today is about getting started with DevOps metrics. This session aims to provide an overview of DevOps metrics for DORA metrics and other metrics with GitLab. And we're hoping to identify opportunities for greater efficiency and correlating those opportunities with business value, connecting the entire organization with a common goal and vision. Right. For our agenda today, we'll start by covering DORA metrics, what it is, and why it's important. We'll take a look at the value stream analytics. We'll also look at insight dashboards, where you can find these items in GitLab, and then we'll round out with additional metrics available on GitLab. As Taylor mentioned earlier, if any questions come up throughout the session today, you can drop them in the Q&A portion, and one of my awesome colleagues will help get your questions answered. All right, let's go ahead and get started. First, I'd like to take a step back and talk about what DORA metrics are and where it came from. DORA stands for DevOps Research and Assessment. After 8 years of data collection and research, DORA's Accelerate State of DevOps Research Program has developed and validated 4 metrics of software delivery performance and a 5th metric called reliability. In the session today, we'll cover the first 4 DORA metrics, which are deployment frequency, lead time for changes, mean time to recover, and change failure rate. Why do we care about tracking DORA metrics or any metrics in general? So ROI for DevOps is tricky since it's hard to put a price tag on a process and not a commodity. But DevOps requires a huge investment in every organization. And oftentimes, executives want to know what they're getting in return. And using metrics can help improve DevOps efficiency and communicate performance to business stakeholders, which then can accelerate business results. So the 4 DORA metrics that we'll look at today, deployment frequency, GitLab's take on it is the average deployment frequency to production. Lead time for changes is the median time it takes for a merge request to get merged into production from master. Change failure rate is the percentage of deployments that cause an incident in production. And time to restore service is the median time an incident was open on a production environment in the given time period. So who should be involved when it comes to metrics? And the answer is everyone. Everyone's contributing is involved in generating the metrics and everyone on the team. So this can include the developers, testers, managers, security folks. And you can do this by having everyone on the team continuing to contribute on GitLab simply in the normal way that they do. And these metrics can help be involved in driving business decisions from the team. Okay, so where do we find DORA metrics? At the moment, there are several different places in GitLab where you can find DORA metrics. They're available in GitLab CI/CD analytics, group level value stream analytics, Insights dashboard, and APIs are also available for all 4 DORA metrics. We'll touch on each of these today as we go through the session. So, as mentioned earlier, the DORA metrics can be found under the CI/CD analytics page, both at the group and project level. Once on the CI/CD analytics page, there are various tabs on top where you can toggle over, and each tab represents one of the 4 DORA metrics. Here on the screen, we'll first start exploring the deployment frequency, and then on the following slides, we'll explore the other metrics. So under deployment frequency, we'll see all the successful deployments to production. This measures how often you deliver value to end users. A higher deployment frequency means you can get feedback sooner and iterate faster to deliver improvements and features. GitLab measures this as the number of deployments to a production environment in the given time period. The chart shown here is an example of how deployment frequency is visualized. We have the option to view the data for the last week, last month, and last 90 days. The red line that we see across the chart indicates our average for that time period. Okay, next we can find lead time for changes under the same analytics page by toggling over to the next tab. Here, we're looking at the time it takes for committed code to successfully run in production. This reflects the efficiency of CI/CD pipelines. In GitLab, lead time for changes calculates the median time it takes for a merge request to get merged into production. And this is measured from code committed to code successfully running in production without adding the coding time to the calculation. We are calculating a median instead of average since there are times that no deployment to production happens. For example, maybe over the weekends. And we want to give a true sense of what the lead time for change really is. Over time, what we want to see is this metric should decrease while your team's performance should increase. And this is also supported at both the group level and project level. In the chart shown here, the gray dotted line shows no merge requests were deployed during that period. Similarly, the change failure rate can be found under the CI/CD analytics page, also on one of the tabs on top. This is also available at both the group and project level. The change failure rate chart here shows information about the percentage of deployments that cause an incident in a production environment. For example, this can be a deployment failure, a security incident, a rollback, or remedy. This is measured as the number of incidents divided by the number of deployments to a production environment in the given time period. So how does GitLab know when an incident occurs? You must use GitLab's incidents for incidents to be captured. And for our 4th metric today, DORA metric, the time to restore service can also be found under the CI/CD analytics page. This shows information about how long it takes an organization to recover from a production failure or failure in production. So it gives us a better understanding of our software stability and reliability trends over time. The way that GitLab measures this is we're measuring this as the average time required to close the incidents in the given time period. And this assumes that all incidents are related to a production environment. And it also assumes that incidents and deployments have a strictly one-to-one relationship. An incident is related to only one production deployment, and a production deployment is related to no more than one incident. So in addition to viewing the DORA metrics in the UI under CI/CD Analytics page, you also get to see project level and group level DORA metrics. You can get those through the API. And this is helpful if you want to see metrics beyond the 90 days that's shown in the UI. Through the API, you can enter in your date range and see the DORA metrics through there. All right, so we took a look at the CI/CD Analytics and pulling it from the API. Next, we'll take a look at Value Stream Analytics and how DORA metric looks there. So Value Stream Analytics collects and shows data across the entire software lifecycle with no integrations to be managed. This is a no-code Value Stream Analytics dashboard where you can use a single click to drill down to investigate further. A value stream is the entire work process that delivers value to customer. This helps provide insights into the items that took the most time in a stage and allows you to drill in to find maybe what caused that delay. On Value Stream Analytics, you have the option to sort and filter by labels and timestamps that you're interested in investigating further. You can even test and compare different approaches over time to see which process improvements help with efficiency and maybe which ones caused additional idle time. To view the Value Stream Analytics for your group, you must have at least the reporter role, since Value Stream Analytics only show custom stream created for your group. You will need to create a custom value stream, and then we'll go over how that looks on the next slide. But the overview dashboard, similar to the one shown here, has key metrics and DORA metrics of group performance. Depending on the filter you select, the dashboard will automatically aggregate DORA metrics and display the current status of the value stream. This can be helpful if you want to measure the amount of time it takes to go from an idea to production. It can also help measure the velocity of a given project and see bottlenecks in the development process. You can see which stages are taking the longest to complete. And when we combine both DORA and Value Stream Analytics, DORA will help you benchmark against industry standards, and then Value Stream Analytics will help you identify, improve, and better DORA metrics. So when you go about creating a value stream, you can use GitLab's default stages and hide or reorder them to customize it to align with your own development workflow. You can also create custom stages in addition to those provided in the default template. Here we have an example of how to edit an existing value stream, and you can see we're using scope labels for the workflow stages. Here we have an example of the 4 DORA metrics and how they look in Value Stream Analytics. This helps you visualize the engineering work in the context of end-to-end value delivery. One thing to note is the lead time for changes is not the same as lead time. In Value Stream Analytics, lead time measures the time it takes for work on an issue to be moved from the moment it's created to the moment it's delivered or closed. On this example, this shows how you can use value stream analytics to find bottlenecks in the workflow. So for each stage, a table list displays the workflow items filtered in the context of that stage. The table provides a deep dive into the stage performance. Here, we're looking at the staging stage, and below we have a merge request, last event, and duration column. From here, we can take a look at the table to see there's a merge request from 3 days ago that took 8 hours, which is significantly longer than other ones that we see here. So from there, we can investigate further. And this is available on GitLab from versions 14.4 and newer. All right, so we covered CI/CD analytics and we covered Insights dashboard. Sorry, I meant to say we covered CI/CD analytics and we covered value stream analytics, and now we are going to dive into Insights dashboard. All right, so Insights gives you an option to configure a custom report for insights into your group's processes, such as the amount of issues or bugs and merge requests per month. You can configure the insights to see data about your group's activity, such as triage hygiene, issues created or closed in a given period. You can also see the average time for merge requests to be merged, and then you can also create custom insight reports that are relevant to your group. This is available both at the group and project level, and then we'll look at how to customize this. So here we have an example of a insights configuration file. The GitLab Insights YAML file is a file where you can define the structure and order of charts in a report. And you can also define the style of charts displayed. For example, you have options like bar chart, line chart, stack bar chart in the report for your group or project. So in this example, we're looking at a single definition that displays one report with one chart. In the file, the configurations parameters define the chart behavior, and each report has a unique key and a collection of charts to fetch display. And each chart definition is made up of a hash composed of key value pairs. Here we can see that we also have DORA metrics under Insights. We added DORA query parameters to Insights, and you can track metrics improvements, understand patterns in metric trends, and compare performance between groups and projects. Insights reports are configured with the YAML file similar to the example that was shown earlier, and can be shared across organization as a single place for everyone to see the same metrics in the relevant context. All right, so here we're going to start to take a look at the different metrics that are also available on GitLab. First, we have the DevOps Adoption Report. The DevOps Adoption Report shows you how groups in your organization are adopting and use the most essential features of GitLab. For example, on the screen here in red, we can see the development category, and it has approvals, code owners, issues, and merge requests as the features below it. A feature is shown as adopted when a group has used the feature in a project during the time period. This includes projects in any subgroup of the group. For example, if an issue was created in a project in a group, the group has adopted issues in that time. DevOps adoption can help identify specific subgroups that are maybe lagging in their adoption of GitLab features, so that way you can help guide them on their adoption journey with DevOps. You can also find subgroups that have adopted certain features and provide guidance to other subgroups to help them use those other features. And you can also use DevOps adoption to verify if you're getting the return on investment that you expected from GitLab. All right, so if you are using code review feature in merge requests, you can look at the time it takes for a merge request to open to the time it's merged. You can find this information under Code Review Analytics to see the longest running reviews in open merge requests and take action on those individual merge requests. For example, a high number of comments or commits can indicate maybe the code is too complex, or maybe authors require more training. A long review time may indicate the type of works that move slower and other types, or opportunities to accelerate your deployment cycle. This can help reduce the overall cycle time and help give insight to make improvements within the teams. The code review analytics can be found at the project level. Next, we have contribution analytics, and you can get an overview of the contribution events in your group. This page allows you to analyze your team's contribution over a period of time. You can identify opportunities for improvements with team members who may benefit from additional support. And on contribution analytics, there are 3 bar graphs that illustrate the number of contributions made by each group member. You can see push events, merge requests, and closed issues for each group member. You also have the option to filter by time period and a number of other factors such as the member's name, number of pushed events, number of opened issues and closed issues, opened MRs, merged MRs, closed MRs, and total number of contribution. One thing that we want to note is we do not advise people getting into a competition. Although it is useful to see who is some of the more active members, there's also a view where you can go to your user profile on your instance where you can see a heat map of your activity. You can use this information to see when folks were busy or less busy. And this is useful for discovering team members that might be contributing too much and are maybe at risk of burnout. And alternatively, maybe you'll find folks that are disengaged and not contributing enough. So this page helps highlight the information that you can use to help with a balancing of the workload. Merge request analytics shows the number of merge requests your organization merged per month. It also shows the average time between merge request creation and merge. And you can see information about each merged merge request. You can use this to identify low or high productivity months and the efficiency of your merge request process and code review process. And then you can use this information to make modifications to your process as needed to drive efficiency. The merge request analytics is available at the project level. So at the group level, you can use productivity analytics to view merge request statistics for your group. For example, you can see the amount of time between merge request creation and merge. You can also view the amount of time between commits, commits, and merge, and see complexity of changes like numbers of line codes per commit and number of files. This can help you identify different things such as your deployment velocity based on how long it takes for a merge request to merge. And you can also find the most time-consuming merge requests and maybe their potential causes. Next, we have repository analytics, and repository analytics shows you how many programming languages are used in the repository and some additional Git repository information, such as code coverage history from the last 2 months. In addition to seeing the programming languages, you'll also find average commits. There's also an option for you to download code coverage statistics raw data in the CSV format. The screenshot shown here is actually of our GitLab repository, and since all of our backend code is in Ruby, it makes sense that the biggest chunk is Ruby. All right, so users can create their own individual operation dashboards where they can monitor different projects. The operations dashboard shows a summary of each project's operational health, including pipeline and alert status. This can be great for leads, team leads, or even group leads. At a glance, you can see if the pipeline succeeded or if it's currently running or failed. You can also look at when the last commit was. When you click into one of the cards, it'll take you to that specific project. And along the same line of operational dashboards, we also have environments dashboard. And this provides a cross-project environment-based view that lets you see the big picture of what is going on in each environment. So from a single location, you can track the progress as changes flow from development to staging and then to production, or maybe through any series of custom event flows that you can set up. The operations and environments dashboard share the same list of projects. So adding and removing a project from one place will add and remove the project from the other. This dashboard can be helpful because at a glance, you can view multiple projects. You can instantly see which pipelines are green and which are red. And this allows you to diagnose if there is a block at a particular point or if there's more systematic problems that you'll need to investigate. To get to the environments dashboard, you'll navigate to the main menu, and towards the bottom of the menu, you'll see environments, and from there you can begin adding. All right, so next up, we will take a look at a number of different security reports and insights that's also available. First, we have the security dashboard, and this dashboard allows you to view trends about vulnerabilities detected by the security scanners. These trends are shown in projects, groups, and the security center. The security dashboard shows results of scans from the most recent completed pipeline on the default branch. Since dashboards are updated with the results of completed pipelines run on the default branch, they do not include vulnerabilities discovered in pipelines from other unmerged branch. When you're on the security dashboard, you can hover over the chart to get more details about the vulnerability, and you can view the chart and the trends over a 30-day, 60-day, or 90-day time frame. And if you want to view aggregated data beyond the 90 days, then you can use the API. GitLab retains the data for 365 days. All right, so when it comes to security insights, the vulnerability reports provides information about the vulnerabilities from scans of the default branch. You'll see results of a successful job, regardless of whether the pipeline was successful or not. The report is available at the group level and project level. On the report, you have the option to filter, set a status, and drill in to see each vulnerability. You also have the option to export details of the vulnerabilities listed on the report. The format that I'll export to is CSV. So when you're on the report and you click in to the vulnerability, each vulnerability has a vulnerability page. For example, from the report that we see here, we click into the vulnerability, it'll take us to the vulnerability page where we can see more details about that vulnerability. On the page, you can take action to either change the status, resolve the vulnerability if a solution is available, view security training specific to the detected vulnerability, and create an issue. You can create the issue to track any actions taken to resolve or mitigate it. By default, you can create a GitLab issue, or if you have Jira integration set up, then you can create a Jira issue. Next, we have the compliance report. This report gives you the ability to see a group's merge request activity. It provides a high-level view of all the projects in the group. You can use the report to get a list of compliance violations from all merge requests within the group. You can use the report to get the reason and severity of each compliance violation and a link to the merge request that caused the compliance violation. To view the compliance report for a group, the user must be an admin or have the owner role for the group. If you're using GitLab CI/CD, you can use license compliance to search your project's dependencies for their license. You can then decide whether to allow or deny the use of each license. For example, if your application uses an external or open source library whose license is incompatible with yours, then you can deny the use of that license. You can select a license to see additional details. When GitLab detects a denied license, you can view it in the license list. And next, we have the Policies tab, where you can view and modify existing policies. All right, so coming towards the end here, we have the dependency list. You can use the dependency list to view your project's dependencies and view additional details about those dependencies. This includes their known vulnerabilities. You can find the dependency list under your project menu and select security and compliance from the dropdown, and then there's dependency list. This information is sometimes referred to as a software bill of materials, SBOM, or just BOM. We recommend not changing the default behavior of allowing the secured jobs to fail because the dependency list only shows the results of the last successful pipeline to run on the default branch. GitLab's dependency scanning or container scanning CI job must be configured in your product for you to see project's dependencies. Your project also has to use at least one of the languages and package managers supported by Gymnasium. The dependency list shows the path between a dependency and a top-level dependency it's connected to, if there's any. There are many possible paths, but the user interface shows only one of the shortest paths. You also have the option to download your project's full list of dependencies and their details in a JSON format. All right, and we have made it to the end of our session today. Wanted to open up the floor for any questions.
Thanks, Alex. Yeah, before we jump in, and we do have a couple that came through, just wanted to let everyone know that we've opened up a feedback poll. We'd love to have you all take just a minute to answer those couple of questions on feedback for today's session. And with that, we'll jump into some of the questions here. So the first one that came through, Alex, are DORA metrics available through the API?
Yes, the DORA metrics are available through the API, both at the project level and at the group level.
Great. Next one here. How can I see the DORA charts? We're a premium self-managed customer, and I don't see DORA metrics under my CI/CD analytics.
Yeah, so DORA metrics are available at our ultimate tier at the moment. If you are interested in seeing the DORA charts, I would recommend to reach out to GitLab team member or let us know in the chat here and we can help see if a trial is something that you're interested in.
Awesome. What report should I want if I want to start getting data around where my team is spending more of their time?
Yeah, I would probably say there are several different reports that you can look at. A good starting point might be the productivity analytics. And then there's value stream analytics that could be helpful if you're on Premium Ultimate, which allows you to create your own workflow. And then from there, you can investigate what's taking the most time in the different stages.
Great. Last one here. For change failure rate metric, how does it know when there's an incident?
So at the moment, the way that GitLab knows when an incident occurs is when an incident is created in GitLab. So you'll have to use the incident management through GitLab and create incidents through there. This can be done automatically or manually for it to be calculated with change failure rate. And we also have integrations as well.
Great. Thanks, Alex. With that, we will wrap up today's session. Thank you, everyone, for joining us. And like we said at the beginning, we'll be sending out the recording and the deck that Alex went through here in the next couple of days. Thanks, everybody.
Awesome. Thank you, everyone.